Okay, good afternoon. Any questions before I get going? Questions? No questions? Yeah.
Shall we publish the issues tomorrow?
Yes. So on Thursday, what what I expect is that first of all that I have all of your repos. I think right now I have about half. So if you haven't yet sent me your group repo, make sure to invite me. And so I will be looking and see, are there some issues there, or uh, to, and we'll just look at it together. So I will pick a couple of groups, and I can't do it with all of you in one lecture, otherwise we'll never make progress. But we'll go through there and see if they are in good shape. So I'm expecting to see some issues. I'm expecting to see some amount of code. So what I'm going to be doing is I'm going to be cloning in front of everyone else a couple of these repos. I'm going to try to figure out to build it. Now, if you're starting with Violet, it would be a good idea if you simply, checked in the current Violet. And, you could make one change and somewhere put in your names in a splash screen or some such thing. So just make some simple change that shows that it's now yours. Check it all in. Make it with Violet. It has an Ant build script, so that should probably just work out of the box. Try it out. So if I see a build.xml, I'll just type Ant and see what happens. With those of you who do the phone thing, it has a Gradle build script, so I'll just type Gradle whatever, and it should presumably build by itself. Right now, what phone application can you do, right? I mean, you know nothing, so it's pretty much going to have to be one that just does something trivial. So I just want you to just put in something that already works, so that that there's always something that builds. There was also some confusion about the individual versus the team reports. So your individual reports, where you just write down how many billable hours you have spent on this already, those go into your individual repo, the one that you've been using all semester. And those are confidential. You can say anything terrible about your teammates that you like. Only I get to read them. Of course, that would be one avenue for you to tell me that there's some problem with the team, maybe something that you need me to know about, or like that, some teammate never shows up, and now you don't know how you're going to divide the work. If you have any kind of things, those you can of course send me an email if it's urgent, or if you just want me to know, then you can put that on your weekly progress report. That one does not go onto the team repo. So the team repo is just the stuff that's needed, design documents, that kind of stuff. So the other thing that I wanted to know tomorrow, on Thursday, is you should make a wiki page. That way, A, I can see that you can make a wiki page, and B, I want to know, what do you think your thing is going to be able to do in 6 weeks? Is it 6 weeks? Maybe only 5 weeks, huh? In whatever, by the end of the project. So tell me, are you going to support all the diagram types that Violet supports? Are you just going to do class diagrams? What kind of user-facing features do you think you're going to be implementing? Of course, this is not a very scientifically run project with a ton of project management. You may be wildly wrong. Maybe you underpromise and later it turns out you can do so much more. Or maybe you don't know how complex it's actually getting and you won't get everything done. That's fine. I just want you to start thinking about what it is that you can do. If this was a real software engineering project, we'd have much more upfront planning, but we don't have time to do upfront planning. So we'll do it the seat of the pants way. So I want a wiki page. I want I want some issues. That way I can see that you can use those things. And I want some code. Those are the 3 things that you need to achieve between today and Wednesday night. Okay, the deadlines are always just like before. I would check out everything early Thursday morning, like at 6 o'clock when I get up. All right, so any other questions? We beat this to death? Then let's go through the lecture. So I'm going to be talking about Android programming a bit. So you know all about what Android is. It's this mobile operating system. It's on a lot of your phones. It is interestingly open source. So in theory, people could take the entire Android system and build it on a phone that has nothing to do with Google. And people have done that. For example, at one point, Amazon developed its own phone, and it was based on a version of Android that Google had no control over at all. Amazon had its own app store and everything. It was a financial flop, so they discontinued it. There's some places in other countries where this is commonly done, where Google really is completely cut out of the picture, and people just run their own versions of Android. And so you could too, if you wanted to. It's a complex undertaking, so it's unlikely that you would individually want to do it. You can get this thing called CyanogenMod that has Android but none of the Google code on it, and run it maybe on an older phone. I did that once or twice to keep an older phone alive. So it's Linux based. So just like most other computers in the world, these ones too run Linux, and you can in fact, as we're not going to do it in the labs today, but you could do it at home. You could just make a shell and shell into your phone, and you can issue the normal kind of Linux commands that you like. It's based on a version of Java, but it's a little bit complex. It uses the Java language, not the most modern Java language, but it's a slightly older one, but it does not use the Java virtual machine. And you may have heard there was a big lawsuit about this some time ago where Oracle sued Google saying that they owed billions of dollars because Google stole Java, and they've lost, and then they've won an appeal, and it got sent back to the trial court, and now they lost again. So right now it looks like Google is free to do what they're doing. The worldwide market share is large. It's over 85%. And there's really only a few countries where Android does not have at least a 60-70% market share. The United States, where Apple has a healthy market share. There's a few countries, weirdly enough, where Windows Phone is the dominant player, but it's like Belarus or something. I mean, it's not countries, Kyrgyzstan or whatever, not countries that we normally care about. So we cannot, of course, cover all of Android programming in a couple of lectures, and that's not really the purpose either. I give you two useful references. There's a pretty decent book by someone who wrote for the Dital franchise, and I'm giving you the link for the library. You should be able to read that as long as you have a library barcode and a library pin. For some reason, you need a library barcode and not just your university code, because this book is from the San Jose Library. So the city of San Jose, not the university library. Whatever. I've gone there and I was able to read it. I actually bought a copy because it seemed worth it. And then I'm giving you this list of useful code snippets in case you need to do something. That's really mostly for the two teams that are working on Android. The other ones, you're going to have this experience for the next couple of labs, and that's all. So the reason I'm doing all of this is that not because I have any illusion of turning you all into competent Android programmers in a week, but because I want to show you how the kind of stuff that you learn in this design course, how it can make it really easier to master a new platform. And that's, of course, going to happen to you all the time, that you're going to be told, oh, now you're going to have to work on whatever, the smartwatch or something. And you have no idea what the SDK is and what the rules of the LAN are, but it really helps to be familiar with some basic design patterns in order to make rapid progress. So a few concepts that you need to know. An Android app is unlike the Swing app in that it's a disjoint sequence of what's called activities. An activity is a single screen with whatever it is that you have on the screen. And so you know that as a user of one of these phone apps, there's a screen, and then you might hit some button, and it gives you a different screen. They kind of stack up. You can use the back button to go to the previous screen. Each of those screens is called an activity. What's interesting about Android, and really that was one of their original claims to fame, was that that a program cannot just switch between its own activities, but it can say, I want to have an activity of some other program. And then that gets seamlessly sandwiched into the stack of activities. And a common use of that is when a program wants to take a photo of something, it can actually interpose a camera screen from the camera app, like the thing that you use to deposit checks for your bank. They didn't write the camera app themselves. They just say, give me the camera app, and then whatever your favorite camera app might come up depending on how it's been configured. So it might not even be the standard app, but whatever it is that you said should be the app from cameras. Or when an application wants to show a web page, they can just say, I want to have the activity that shows web pages, and then it'll use the one that was pre-configured by you as your favorite way of showing the web pages. So that's a very clever piece of architecture that they did that really has no analog in desktop systems. So here is a super trivial activity. Main activity, and it extends this thing called app compat activity. So one of the things that makes it painful to do Android programming for real is that the API changes all the time, and there's so many versions of the phone out in active usage. So when you program for the iPhone, you can rely on the fact that the iSheep follow what Apple does very regularly, and they will update their phone like almost instantly. With Android, that's not the case because one has to go through the manufacturers, and it's often not possible for you to get the latest version of Android. So there's a lot of versions that are 4, 5, 6 years old. And so they've once again overhauled their compatibility API, and so this week we're supposed to be extending app compat activity. That will undoubtedly change in a year or two, as they have a different way of doing that. So hopefully this thing will get better over time, but right now it's a mess. So you have to override a method called onCreate that gets called when this activity gets created. You can see here a glimpse of another thing that's interesting about activities. When you have a program on your computer, that program keeps on running until you terminate it. That's not true for an activity. An activity can be kicked out of memory just because there's not enough room. It's a much more resource-constrained device than a computer, or at least it used to be. And so when you open more and more activities, then some of the ones that haven't been used for a while, they simply get deactivated, and they get a chance of saving their state. And so when you call onCreate, it passes whatever saved state there was. And so if an activity was smart enough to make it so that it can in fact be kicked out and then come back as if it had never left, then you can do that. This particular activity doesn't really do any of that. It'll just come back in a brand new state. So when you have activities, you declare them in an XML file called Android manifest.xml together with a bunch of other stuff. The main activity has to be declared in this particular way, where we say that it is the main activity. And I don't know what these categories are, but one copies and pastes this file. If you have additional activities, you can just list them here with activity and /activity, and that's all. But you do need to list them. It's a common error to not do that, and then stuff will not work.
So
every activity needs to be listed in the manifest.
Which is any class you build that extends activity.
Yeah. Why they can't Autodesk cover that? Why can't they use annotation? I have no idea. It's the way it is. It's always been like that. So when you lay out user interface elements, it's kind of similar as in Swing. You can do it completely programmatically. So you could write code that makes it that takes a layout and adds components into that. Or you can use a tool that, well, okay, I should say the way I said it in the slide. Or you could specify the layout in XML. Let me show you. Oh, you'll see it. You'll see it in the lab. The advantage of doing it in XML is it's not programmatic, but you just write. It's kind of like writing HTML. The disadvantage is it's of course then completely static. That you can't. It's not as fluid as it would be in Swing. So there's a couple layouts that we will learn. One is called a linear layout, and that can be used to lay out components either horizontally or vertically. You can nest them, and with that you can get some decent arrangements. And then there's what's called a relative layout that lets you specify that one component should be on top of another or to the left of another, and then the layout, the equivalent of the layout manager will then figure out how to follow those arrangements. What most people do is they use the drag and drop layout editor that an IDE provides, and you will do that in today's lab as well. And when you do that, you will find the severe limitations of a drag and drop layout editor almost right away, because you will drag and you will drop and it'll turn into a royal mess. And the easiest way to fixing up that royal mess is actually to turn the thing off, go into XML mode, and to look at the XML that was created and try to whip that into shape. It turns out to be surprisingly difficult to use these drag and drop editors well. If you know what you're doing, it's fine. But so look at the XML and clean it up. Once you have a layout, you can just load it by calling this magic line here. R is another oddity of Android. As you add more things into the resources, they get compiled behind your back into an object of a class that's called R for resources, and it acquires different instance variables. So there's a thing called r.layout, and then once your activity main.xml gets compiled, it gets compiled into this thing r.layout.activity main. So it's an actual Java thing. It's an object has some type, and you can pass it on to this method here, and then the whole layout gets loaded and realized. So that's layouts. They are in this directory called res/layout. And then there is another thing. When you want to have strings, then you put them into res values strings.xml. So you're encouraged to always put any kinds of strings that the user sees, such as hello world or press here or please wait. Any of those strings should be not hard-coded in your program. They should instead be put into strings.xml. And the reason is that way it's easy to internationalize them. So then if you want French strings, you put them in a directory called res/values-fr for France, strings.xml. And you just translate all of the strings. And then your application automatically shows up in French. If you breeze through the lab, you can actually try that out. So when you refer to one of those things, there's a funky notation that you have to use, is you give the thing a name inside strings.xml, and then you can refer it by saying @string/ and then the name that you gave it to. And then that way the correct name, whether it's English or French, will be picked up. There's a similar system with images where you put them into res/drawable, and then you refer to them as drawable/ and then whatever the image name is without the extension. And then you can specify different resolutions for it. Pixel densities vary widely on devices. Some of them are quite old and just have tiny screens. Some of them have screens with lots and lots of pixels. And you can have different directory names with suffix LDPI for low DPI to XXX high DPI right now. Undoubtedly, in a few years, we'll have quintuple X high DPI as these resolutions keep going up. And so you make different subdirectories and you can put the file there. We're not going to do that today. We'll just use one resolution. But it's nice to know that you have that ability. So this idea of resources is it's an abstraction layer where you can deal with changes in the user environment, language, region, or display size. So I'm not actually going to ask you to answer this on cancer today. Just want you to tell me which of these sentences is the most feared one in the English language. So as software engineers, there's no contest, right? The worst thing that you can ever hear is, but it builds on my machine. And so it's important that when you have a team project, that stuff gets built outside your IDE. Your IDE is a beautiful tool for typing and refactoring and auto-completion and looking up documentation and reformatting and all of that. But an IDE is not actually a particularly good tool for building software. And the reason is simple. If you look at a typical IDE like this Android Studio thing here, just looking at it here, it's a little known fact that there are more ways of setting up the configuration for Android Studio than there are molecules in the universe. So the chance of me and you and you and you having the exact same configuration of Android Studio is 0. Right? So everyone has their own configuration somewhere. And so it's a very easy thing for you to click the run button and for me to click the run button and get somehow subtly different results out of it. So you want builds to be reproducible, and that means that you need to have some kind of build tool. The build tool that Android uses is called Gradle, and it's there. There's no use arguing with it. So there's kind of two kinds of build tools. There's this thing called Ant that those of you who are using messing with Violet will see. And Ant is kind of low-level, primitive. You say exactly what steps should be done for building. Gradle is very high-level, and you kind of give your intent of what you want to achieve, and then it has recipes on how that should be realized. The difference is that with Ant, when something goes wrong, you can figure out what goes wrong. With Gradle, they're Googling at Stack Overflow, trying to figure out how to mess with it. So I'm not too much of a friend of Gradle, but it is what it is. So the way that you use it to build something, and that's what we're going to be doing on Thursday for those of you who submit me some Android stuff, is you type this command Gradle W, assemble debug, then it goes off and builds your entire thing. And in fact, Android Studio does that for you. And you will notice in the lab today, because whenever you sit there for 30 seconds and you know what the heck is happening, there'll be some spinning bar on the bottom that says it's running the Gradle build. For some reason, it's slow as molasses. To run the program, there's some commands that are issued, which also Android Studio will issue for you, but it's nice to know that you can do those by hand. And so I've put them here if any of us ever needs them. A couple more things you need to know. The component IDs that you need to assign, and they're automatically assigned by the builder, but it's usually a good idea to clean them up. So, for example, when you have a button or something, or a text, in this case would be a text field, then you would want to give it in the XML where you make the button, you say, make an ID, and the plus means make a new one, increment whatever your counter was, and call it result. And then later you can use, I guess this is a typo here. It says get as r.id.result, and I meant to say r.id.result, and things that way. So to find the ID in the code, you have to use this find view by ID, and then give it the ID here. Then you have to cast it to what actual type it is. There's no way for it to look this up. And then you can put something in. Buttons are almost like in Swing, but not quite. In Swing, remember what you do to a button is you add a listener. Swing uses the observer pattern. Observer pattern says you want to observe changes in something, you add a listener. Anyone can add listeners. You can add as many listeners as you like. It's not quite as nice in Android. You call set on-click listener, which means you get to have at most one listener. If you you want to have two different pieces of code be notified, then you have to implement that by hand. Why did they do it like that? I have no idea. But then you specify, now the other thing that's not so nice is, right now we don't yet have Java 8 for Android. It'll undoubtedly come at some point, but right now it's stuck at Java 7. And so you have to use this horrible way of doing anonymous inner classes. So you say, I want to have a new view.onClickListener, and this is the method that I want to override, and then you put your code in here. You don't have the Lambda expression where you can just say event arrow. Actually, there is some way in Android Studio that you can hide this thing, and it makes it look as if it was a Lambda expression, but it really isn't one. So I would suggest you just copy and paste that when you need a listener and just fill it. I think that's all you need to know, exactly. So now you know enough Android programming to program a simple app, and so that's what we're going to do in the lab right away. So I asked you to set up your environment, which I hope you did, because you're going to need it now. And just pick up with that Hello World application that you'd built, the one that looks like that, and just whack away at it and put an image on it. And that way you'll get to see the lay of the land of Android Studio and so on. And then the next thing after that is to make a new application that uses buttons. And I'm having the simplest possible application here. It's a true-false quiz thing that has one button that says true and one button that says false. And that way you get to mess with the buttons a little bit. And if you have extra time, then you can make your app in French or whatever your favorite language is. All right, so work in groups of two. And so if there's anyone who does not have Android Studio running on their computer right now, please team up with someone who does.